This is a demonstration of the collection and analysis of a concentric only, or what is termed a squat jump, using the BMS .NET software. After opening the application, we'll load a squad file, clicking on Open Squad File of Squad. This will be loaded. More details regarding squad files will be explained in a subsequent instructional video. From here we can select a particular squad member. We'll then go to the dashboard and commence data collection. There are some options to set up first, and these include the sample rate, which can be adjusted to whatever appropriate, for example 1000 Hertz. We then have various cutoffs, frequency cutoffs for the filters for each of the data sets: displacement, velocity, acceleration and force. These are the default values, but of course they should be adjusted relative to the particular type of data being collected and the hardware being used. Just before commencing data collection, it is advisable to zero the force and or displacement depending on which transducers are connected to your particular system. If you then select Dashboard and click the Start button, data collection will commence. The data is collected, as you can see. This is for a, for a squat jump where there's no counter movement. The next phase is to calculate the remaining data sets of acceleration and velocity and power. To do this, we have to set the mass. The system does average the entire force signal to get an approximation of the body mass, but you can see that there is some deviation here at the end where the athlete is moving after the jump. So I would suggest that you actually choose a very flat section of the force trace and click on Set Mass to get a more accurate indication. Click on Velocity and then Calculate from Force, and the system will calculate the velocity of the center of mass. To operate the graph, it's fairly straightforward. To zoom in, simply select the starting point and then just select the data you wish to zoom in on, and that data will be zoomed and scaled appropriately. To unzoom, again, it is a left mouse click and sweep upwards and to the left, and that unzooms. So again, to zoom in on a particular piece of the data, section of the data, left mouse button, hold it down, drag to select the section, and then that will zoom in on that particular section. Now this is a very important function, of course, because it allows you to select the particular time period that you wish to analyze. So for this particular movement, which is a squat jump, my suggestion would be to zoom in initially on this section here, but then we'll choose the point at which they initiate the jump. As you can see, when they first start to actually apply an increase in force, and we'll zoom through to the point roughly at the end when they land, and there we have the zoom portion. Now we can also, if we then select results, then the results are only shown for that zoomed section of the graph. To determine which results are saved, you can deselect all or select all. With them deselected, then you can choose the particular parameters that you wish to save. Some of these rate of force development measures, of course, being a squat jump and time to peak force, quite useful as well, and even some of the impulse measures. Of course, for a squat jump, parameters such as eccentric time are fairly meaningless. There's no eccentric phase. Similarly, eccentric plus concentric time and the flight to contraction ratio are meaningless, so that you wouldn't save those. So we've selected the individual parameters that we wish to save from this particular trial. If we then click on Save to Excel, you can see that the data is written out to an Excel spreadsheet. Because we selected the subject's name from the squad file, it includes their ID, name and body weight, the actual peak velocity, etc., all recorded to the Excel spreadsheet. If we then return to the BMS program and select the dashboard, then a different section of the data can be selected and the results calculated. If you have any questions regarding this video or any of our systems, please do not hesitate to contact us at the website www.innovations.com.